A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hello. We know that joining the ends of the diameter to a point in any part of the circle gives a right angle. The biggest chord in a circle is known as the diameter. What about an angle which is made by a chord and that chord is not a diameter on a point on the circle? That is, look at the figure given. The line AB is a chord and which is not a diameter. We are going to analyze the importance of angles which are made by the chord AB on the upper part of the circle. To analyze the importance of these angles, consider any single angle. That is, the chord AB is making an angle APB at the point P. Join OA, OP and OB. Now, OA, OP and OB represents the radii of the circle. The triangles AOP, BOP and AOB are isosceles triangles as OA, OP and OB are equal. Now assume the angle APO as x degree. If angle APO is x degree, then angle PAO will be also x degree, as the triangle APO is an isosceles triangle. So the angle AOP will be 180 minus 2x. Similarly, in triangle BOP, if angle BPO is y degree, then angle PBO will be also y degree. From this, angle BOP will be 180 minus 2y degree. The sum of all the angles around the point O is 360 degree. That is, angle AOB plus angle AOP plus angle BOP is equal to 360 degree. So, angle AOB is equal to 360 minus angle AOP plus angle BOP. Substituting the values of angle AOP and angle BOP, we will get angle AOB is equal to 360 minus 180 minus 2x plus 180 minus 2y. 360 minus 2x minus 2y. 2x plus 2y. If we take 2 outside, 2 into x plus y. The angle APB is x plus y degree and the angle AOB is 2 times of x plus y degree. That is, the angle AOB is 2 times of angle APB, or APB is half of angle AOB. Once the position of A and B is fixed, changing the position of P may change the values of x and y, but not the angle APB. That is, on the upper part of the circle, the angle APB will be always a constant value, which is irrespective of the position of P. Look at the figure. What if the point P is like this? Consider the triangle OPA and OPB. AO and OP are radii of the circle. So, triangle AOP is an isosceles triangle. Take the angle OPA as x degree. As this is an isosceles triangle, the angle OAP must be also x degree. So, the angle AOP is 180 minus 2x degree. Similarly, OP and OB are radii of the circle. So, triangle OPB is isosceles triangle. If we consider angle OBP as y degree, then angle OPB is also y degree. From this, angle POB will be 180 minus 2y degree. Here the difference of angle OPB and angle OPA will give the angle APB. So, angle APB is equal to OPB minus OPA. That is, APB is equal to y minus x. Similarly, angle AOB is the difference of angle AOP and angle BOP. That is, angle AOB is equal to angle AOP minus angle BOP. Here we know angle AOP is equal to 180 minus 2x and angle BOP is equal to 180 minus 2y degree. Then angle AOB is equal to 180 minus 2x minus 180 minus 2y. Angle AOB is equal to 180 minus 2x minus 180 plus 2y. That is 2y minus 2x. The plus 180 and minus 180 will cancel out each other. So 2 into y minus x. Now we got angle APB as y minus x and angle AOB as 2 into y minus x. Here also the angle made by the endpoints of the diameter on the center is double of that of angle made at the point on the circle. That is, the angle made by the chord on the center is always the double of angle made by the chord on the outer part of the circle. Now let us consider the angles that is below the chord. In the figure, consider the point Q. Now we are going to analyze the importance of the angle AQB. AO and QO are radii of the circle. So AOQ triangle will be an isosceles triangle. If angle OAQ is x degree, then angle AQO will be also x degree. Then angle AOQ will be 180 minus 2x. Similarly, BO and QO are the radii of the circle. So again triangle BOQ will be an isosceles triangle. If angle OBQ is y degree, then angle OQB will be also y degree. Then angle BOQ will be 180 minus 2y. Here angle AOB will be the sum of angle AOQ and angle BOQ. So angle AOB is equal to 180 minus 2x plus 180 minus 2y. Now let us assume angle AOB as C degree as shown. C is equal to 180 minus 2x plus 180 minus 2y, where angle AOB is C degree. C is equal to 360 minus 2x minus 2y. That is 360 minus, if we take 2 common outside, 2 into x plus y. 2 into x plus y is equal to 360 minus c. Now dividing both sides by 2, we will get x plus y is equal to 180 minus half of c, where x plus y angle is angle AQB. So angle AQB is equal to 180 minus half of c, where c is the center angle, that is angle AOB. So angle made below the chord is 180 minus half of the angle at the center, that is 180 minus half of angle AOB. From this we can conclude the concepts as any chord which is not a diameter splits the circle into two parts, one bigger part and one smaller part. The angle that is made by the ends of the chord with any point on the bigger part of the circle is half of the angle made by the ends of the chord with the center of the circle. The angle got by joining any point on the smaller part to the ends of the chord is half the angle at the center subtracted from 180 degree. Now look at the given circle. The circle is divided into two parts by two radii, a red portion and a green portion. Consider the arcs of two parts. Each of these arcs can be called the alternate arc or complementary arc of the other one. Consider the center angles as C degree and D degree. If we take the sum of these central angles as sum of that will be 360 degree. We already learned that the angle made at the bigger arc is half of C and angle made at the smaller arc will be half of D. Then what will be the sum of the angles made at both the arcs? That is half of C plus half of D. We know that C plus D is 360 degree. So half of C plus half of D will be 180 degree. So the sum of angles made at both the arcs is 180 degree. These type of angles is known as supplementary angles. That is, sum of two angles is 180 degree, then such type of angles is known as supplementary angles. Now let's conclude 2 points. All the angles made by a chord or arc on the alternate arc are always equal, and pair of angles on an arc and its alternate arc are supplementary. We can use this principle to halve any angles. Now if we need an angle of 22.5 degree, draw an angle 45 degree. Now by taking the corner of angle as center of the circle, draw any random circle. Now extend one side of the angle as shown. Mark the point which is the meeting point of that line with the circle. Now join this point with the other point where the other side cuts the circle. Then the new angle formed gives us the half of angle 45 degree, that is 22.5 degree. If we repeat the process again, we will get another angle that will be half of 22 1/2 degree, that is 11 1/4 degree. We can also use this concept to draw the triangle with specified angles and circumradius. Just look at an example. Let us consider a triangle with angles 30 degree, 70 degree and 80 degree and of circumradius 2.5 centimeter. Let us draw this triangle with the concepts we learnt. Now the angles of the triangles is 30 degree, 70 degree and 80 degree. So if the triangles are making these angles, then the center of the circle angle will form the double of these angles, that is 60 degree, 140 degree and 160 degree. Now draw a circle of radius 2.5 centimeter. Then mark an angle 60 degree at the center as shown. Then mark the angle 140 degree. Then the third angle at the center will be 160 degree, because the sum of angles at the center is 360 degree. Now mark all the 3 points where radii touch the circle. If we join all the 3 points, we will get the triangle which have angles as 30 degree, 70 degree and 80 degree. We will learn more about circles in coming sessions. All the activities in the chapter will be available under the icon Maths Lab.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.